first three in the will precipitate form are the easiest one. Very straightforward questions that, given these two concentrations, 0.035 molar lead ions and 0.15 molar chloride ions, will the precipitate form? You always need to make sure that you examine the equation, because this is how we get our Ksp expression. So these two things, lead and lead chloride, would have to combine in a 2-to-1 ratio, 2 chlorides for every 1 lead. Once you know that, the Ksp expression is easy, noting that we've got our 2 up here. So we just substitute these numbers into these places. When we put them in, we evaluate it, and we find out that Q in this case is 7.88 times 10 to the minus 4, and then we make the comparison. This is greater than Ksp, so a precipitate forms. Remember that when Q is greater than Ksp, it means that we have too many on the reactant side over here, so that it has to go backwards to the product side, and this is the solid, so that's why we get a precipitate. For all of these problems, the K values are on the first graph. So looking at the second one, two different ions, strontium ion and carbonate ion. This time, when we look at how they would combine, since they're both the same number, 2 plus and 2 minus, it's a 1-to-1. That gives me a Ksp expression, 1-to-1. So I now just have to substitute in for both of them and evaluate it. 1.8 times 10 to the minus 5. When I compare this Q value with the Ksp for strontium carbonate, I find that Q is greater than Ksp. So once again, a precipitate is going to form. The last of these ones gives us a system we've seen before, the lead chloride system. And this time, the only thing different is what numbers we're plugging in. So exact same system, it's just we started with different numbers up here, so we substitute in different numbers. 2.02 times 10 to the minus 6. This time Q is less than Ksp, so a precipitate does not form.